Now, the reason the SI system spread around the world was because of its simplicity. The base units can be used to build units for anything. Let's see how that happens. Suppose I want to build some base units for speed. Now, speed is defined as distance that you travel over a period of time. You know, units like miles per hour, that's distance in miles per hour that you've traveled, would be a speed. But in the SI system, distance is a length, right? So your units would be meters for distance per second for time. So you put in the SI base units here. This would be the SI derived unit for speed. Now you can write it like this, or you can write it like this, or you can write it like this. Now notice I've used a little exponent there. Now we've looked at powers of 10 earlier on in the lesson, and when you've got a negative exponent, it means 1 over something. So if you have seconds to the minus 1, it's 1 over seconds. So all of these things mean the same thing. They're all just the same unit written down different ways. All right, let's try another one. How about acceleration? Your acceleration is how much your speed changes over time. So, if you go from 0 miles an hour to 60 miles an hour, in a second, that's a measure of your acceleration, how fast your speed is changing. Now, let's do the derived unit for that. Well, we've already seen that the derived unit for speed is meters per second. And for time, it's seconds. So that's kind of ugly looking. We can simplify this. Just like x's and y's in an algebra equation, units can be manipulated and simplified. If I have meters per second, I can also write that as meters per second squared. Or I could write that as meters seconds to the minus 2. So you can see the units written down in any of those ways. This way and this way are a little bit easier to read than this way, so nobody really does it that way. But you can see them in different forms like this. What about force? Well, I need some kind of a physical definition of force. I had a definition for speed, and that allowed me to derive units for that. I had a definition for acceleration, and I could derive units for that. What's my definition for force? From high school physics, force is mass times acceleration. So if I want an SI unit for that, I can take the SI unit for mass, a kilogram, and multiply it times the SI unit for acceleration, which we just worked out. And I have that lump of units, kilogram meters per second squared. When I say the word per, that always means divided by. All right, I could remember that ugly unit anytime I wanted to write down a force, but there's an abbreviation for this, also known as a Newton, with a capital N. Now, a lot of these units are named after scientists. You know about Isaac Newton, the discoverer of gravity, but when you make him into a unit, he gets to be lowercase. So you'll see a lot of names. The Kelvin that we looked at just a little while ago is also a unit named after a person, Lord Kelvin. So if you write a capital N, That means the same thing as what I have in the circle here. It's called a Newton, that clump of units. That's worth remembering, okay? You could put a box around that. Get into the habit of putting a box around things in your notes whenever it's something that you need to remember. Now, what about energy? Well, I have to know what energy is. Energy has to do with work, and work is pushing something against an opposing force. In fact, you can calculate how much energy you use up when you're doing work by multiplying force, the opposing force, times the distance that you push the object through. So there's the physical definition of energy. And it's got units anyway. This is the physical definition of its units. Force units times distance units. Well, we could write this a couple different ways, right? We can write the force unit as newtons and the distance units as meters, and we could just call the energy units Newton meters. Newtons times meters. But there's an abbreviation for that too. If you take newtons times meters, they call that a joule. Named after James Prescott Joule, and it's lowercase because once he becomes a unit, it's not a proper noun anymore. And the abbreviation for that is a J. That one's worth remembering too. We're going to see a couple more of those as we go through the course. For example, the pressure unit is a Pascal, and it's a clump of units that you derive this way. How else could we write down the joule before we give up on this? Let's write the joule in terms of kilograms, meters, and seconds. Well, it's a Newton times meters. A Newton is really this, so we could write kilograms meters per second squared times meters is a joule. Now if I have meters times meters, that would be meters squared up here. So that's another way to write a joule down. Joule is that. Whenever anybody writes a J, it's just an abbreviation for that.